right, welcome. We're we're gonna just this really is a mini lesson. I think I've been kind of given kind of long lessons here because I get carried away sometimes. But anyway, this is kind of a long. This is a mini lesson. You have two short sports videos I'd like for you to watch. Now be careful because I'm doing a Where's Waldo with them. I'm having you look at these videos and then um, you're going to answer specific questions that they ask or that they reveal. And the nice thing is they're not like 20 minutes long, so you're not sitting there going, well, what's this one going to be? Well, what's this answer going to be? They're they're 3 and 2 minutes long each, so nothing too big. And what we're looking at today is I'm going to make this a little bit bigger. We're looking at sliding, okay, and sliding in baseball, and we're doing this is a baseball unit. It's a small baseball unit. We're gonna look at base stealing and sliding today, and the some of the science behind it. I mean, there's so much. I mean, you could get down to the minutia of just examining the effectiveness of baseball cleats digging into certain soils, which gives you an optimum and things like that. I mean, it's the you can really get into the minutia with engineering and physics. You really can. We're going to keep it not quite that deep into minutia of things, but we're looking at some of the science behind stealing a base and the science in sliding. Okay, and then I kind of make a silly proposal about, well, what if we have someone like Christian Coleman who earlier this summer broke the 100-meter NCAA record in the 100-meter dash at 10.8 seconds, which is uh, um, no, 9.8 seconds, 10.8 seconds. I was going to say the high school kid, a state champion type high school kid to do 10.8. He did 9.8 seconds. And figuring out what I got was he was running about 10.8 meters per second or something like that. But so you'll see what we do at the end there. But anyway, there's only one slide, and I'm going to show that to you now, and that's going to be um, these four equations that we're going to use over the next two lessons, maybe throughout the course, and they're the equations of kinematics, and they're kind of the starting block that we usually start with our physics 210 and 240 students on, getting them to understand physics, and it's probably the trickiest part of the entire course for many of them, because there are certain assumptions that we have to strip away, like the difference that there is a big difference between speed, velocity, and acceleration, and those kinds of things. There's a difference between speed and velocity, as a matter of fact. It depends on the direction you're going and what. But I don't want to go too far down the road. It looks like it is today. I know I want to recycle this course through, so this is September 18th in 2017, and the Royals are toast. The Royals are toast. I mean, they came limping in to Cleveland, of all places to go limping into. They went limping into Cleveland. They played a couple of good games, but they just didn't have it, and they're done. Put a fork in the Royals. It's starting to look like we should have blown ourselves up. The Chiefs, on the other hand, are doing all right. I myself, and I'll probably talk more about it later because I think I'm going to have a small section on mini lesson on brain injuries and things like that. But and so we'll get started.